Good day, everyone. This is Maths with Takanda. We are still under what? Under the first principle as well, in which we are given that we should use the first principle to solve what? When y is equals to what? 1 all over x. And we are asked to what? To use our what? First principle to solve it again. So let's solve it. Let's see if it's simple. Let's solve it. Okay, now let's write solution. Right? This is our solution. What are we given as what? We are asked to differentiate y when it is equals to 1 all over what? Over x. Can you see it? So let's go. So now, for us to solve it, it's still the same principle, which our principle says that our dy dx is equals to, always remember, the limit as change in x approaches 0, right, of f of x plus change in x minus f of what? F of x all over change in what? Change in x. This is our formula whenever we're given first principle to solve. So let's go. Now, our f of x is still the same thing as what? 1 over x. What next? Our f of x plus what? Plus dx. Then our f of x plus what? Change in what? Change in x is equals to 1 all over. Anywhere we see x, we put what? X plus change in x. So in which we have x plus what? Change in what? Change in x. Do you see it? Now let's substitute everything to the problem. To the what? To the what? To the first derivative, that was the formula for us to get what? Our dy dx. Let's substitute. So now we have our dy all over dx is equals to the limit as change in x approaches what? Approaches 0 of what? F of x plus dx, which is this guy, 1 all over x plus change in what? Change in x minus the original guy, which is what? F of x, 1 all over what? All over x. Everything all over what? Change in what? Change in x. Now, we do some manipulations here. It's not, although rather it's not manipulation, but actually that's actually what we are going to do. Now we are having fraction here. Let's take the LCM. Our LCM here is nothing but what? X into what? X change in x. X plus change in x, right? So now, when we do that, this guy will multiply this guy and this guy will multiply this guy, right? That which is correct. So now, which means we have our dy dx is equals to the limit as change in x approaches 0 of when this guy multiply this guy, we have x minus when this guy multiply this guy, we have minus x plus what? Change in x all over their multiple, right? That's x in bracket what? X plus what? Change in x all over change in what? Change in x. Now we are free to bring this guy down. This guy will come down. So which means we are having our dy all over dx is equals to, right, the limit as change in x approaches 0. Since we have x minus what? X minus x plus change in x all over x into what? X plus what? Change in x, then change in x, right? We have this guy like this. So what do we have next? This and this will go, in which we will now be having dy all over dx. When this and this go, we will remain this, right? We have is equals to the limit as change in x approaches 0, right? Of what remains at the numerator is minus change in what? Change in x all over x, in bracket x plus what? Change in x, the what? The x. Right? So now, this dx will cancel this, remains 1 all over, or minus 1 over this, right? In which we now be having our dy all over dx is equals to the limit as change in x approaches 0. What remains here is what? Minus 1 all over. What remains at the denominator is what? X in bracket what? Yes, x plus what? Change in what? Change in x. we can still do something. Let's multiply through by this x that remains here, right? In which we'll now be having our dy all over dx is equals to the limit as change in x approaches 0, which is minus 1 all over, we have x squared, right, plus x changing what? Changing x. But when this guy approaches 0, everything turns to 0 at this point, right? So in which what left is what? Dy all over dx is equals to minus 1 all over what? Over x squared. So that is what? The derivatives of what? 1 all over what? All over x. Thank you for watching. Like, comment, share for others to what? To learn. Thank you.